Hello everyone and welcome back to EdTech. Today, let's solve the daily LeetCode problem. 2559. Count vowel strings in ranges. We will dive into several approaches. We will start from the first, most intuitive one, and then we will improve it step by step. We will come to the most efficient solution using a prefix sum that will beat 100% solutions in the LeetCode for this task. So here we are given two arrays, array of strings, words, and another array is array of arrays actually. This is array, this is array of arrays, queries, notice that number of words, let's say n, doesn't need to be equal to number of queries. Let's mark it as n. So with queries, we are given some ranges. Left limit is start, right limit is end, and so for each range. And we need to check for each query words in that range. When we are considering first query 0, 1, that means that we are considering words from 0 to 1. So add and tag. So based on queries, we need to form our result. So for this query, we are considering words 0 and 1. This doesn't satisfy the condition, neither this. So we have 0 words that satisfy the condition to start and end with vowel. From 0 to 3, we are considering 0, 1, 2, and 3. So all words in this array. These two don't satisfy the condition, but this one satisfies the condition. This one doesn't, so we have in total one word that satisfies the condition to start and end with vowel. So for this range, we have one word that satisfies the condition. When we have range 2 and 3, that means we are considering these two words. So we also have one word that satisfies the condition. So one approach could be to start to iterate through queries. So for each query, in queries, we need to check how many words in this range, start and end, satisfy the condition. Result of I, appropriate value that we are dealing with currently, will be increased whenever we find the word that satisfies the condition. That is some idea. Let's try to implement it using C#. So, as we said here, we have n and m, size of words array and size of queries array. We want to iterate through queries and then through words. Let us use for loop instead of for each to keep information about indexes. Query is queries of I. Start limit is only integer, query of 0, and limit this query of 1, and we need to iterate through words. So let us implement this part using for loop instead of for each again. So starting from S up to end, and word is string, words of J. So we need to check if word satisfies the condition. If word satisfies the condition, we need to increase our result by 1. So I index is used to go through queries, and we are going through the result with the same iterator. So that's the reason why we use index I here. And once we calculated the result, we need just to return it. Let us see how to implement satisfies condition method. We are using it just inside this function, so it's okay to be private. It's the bool one, we are using it inside if statement, and it receives only one argument, a string word. And we need to check if both first and last character are vowels. So first character is word of 0, last character is the length of the whole word minus 1. So here we have 1, 2, 3, 4 words. The last word is 3, 4 minus 1. So we vote first and last character are vowels, and the condition is satisfied. So let us implement isVowel method as well. It's Boolean and receives only one character as argument, and character is vowel if it's either A, so let's go once again through our explanation and pseudocode and our implementation. So here we are iterating through queries array. So it's the same as for each query in queries, but we are using a for loop instead of for each to be able to track indexes, because index is important for us to save appropriate value in the result. So query has start and end limit. We are extracting start and end limit from the query. Then we are iterating further through the array of words between start and end. And to make it easier to go through the specific range in words, we are using index and for loop instead of for each. And we are starting from S and going up to E, end limit. And we check for each word, if in that range, of course, if the word satisfies the condition, and if yes, we are increasing the result at appropriate place. After the calculation, we are just returning the result. So let us try to run and submit this code. Okay. So we have time limit exceeded error. Let us see why we have this error. We are dealing with words, and here we have only 4 words. In the first query, we are going through words at places 0 and 1. But in second query, we are going again through words 0 and 1, and we are going through words 2 and 3 for the first time. And here we are going through words 2 and 3 again. So we have multiple some kind of calculations, and we need somehow to improve that, not to check any time if a word satisfies the condition. So we can, instead of calculating this condition each time, we can prepare in advance. So add doesn't satisfy, so we can keep 0. Tech doesn't satisfy. Algo satisfies, and LeetCode doesn't satisfy. We can create another array. It can be int, and we will use 0 if condition isn't satisfied, and 1 if condition is satisfied. And the size of this array will be the same as size of the words, because we are tracking the condition satisfaction for each word. So it's n in our code. So let us prepare the condition first. If satisfies the condition for word, our condition array of yacht will be 1. Otherwise, it will be 0. But this part is not necessary, because once we created array conditions, it will be initialized with all zeros. And here, if satisfies the condition, we just need to check if condition of yacht is equal 1. We are increasing result by 1. If condition of yacht is 0, we don't need to do anything. So we can write these two lines in shorter form. So result of I plus equals condition of I. Because if condition is satisfied, we will increase result by 1. If condition isn't satisfied, we won't increase the result. So let us check this code. Okay, we have some satisfies, not satisfied. Okay, it's accepted. Let us try to submit our code now. Oh, okay. Now it's accepted. We don't have the time limit exceeded error anymore. So the only difference is in this line, we don't check satisfies condition anytime, but we check it once, save indicator in appropriate array, and use that information, which is more efficient operation than checking this condition each time. But it seems that we still have a problem with our runtime. We are not happy with only 10%. So let us see how we can improve this solution further. So previously we had words and we have condition array. So for each word, we have been tracking whether it satisfies the condition. But instead of tracking for each particular word whether it satisfies the condition, let us track for all the words up to that one, including that one as well, whether how many words satisfy the condition. What does it mean? We have the word edtech. it's 0, 1, 2, and 3. And before 0 word, we don't have any words, and word ed doesn't satisfy the condition, so we have 0 words that satisfy the condition before and including a word on index 0. For word tech, previously we had 0 words that satisfy the condition. Word tech doesn't satisfy it neither, so we have 0 words that satisfy the condition up to 1. Up to word 2, algo, we have 1 word. And for LeetCode, previously we had 1 word that satisfied the condition. LeetCode doesn't satisfy, so we have in total 1 word that satisfies the condition up to this one and including it. Let us take a look at some more interesting example. So let us check how many words up to that one and including it satisfy the condition. AB, we don't have any words before, and AB doesn't satisfy the condition. BA doesn't satisfy, and previously we had 0. ABA satisfies, and previously we had 0, so in total it's 1. EEE satisfies the condition, and we are adding 1 to previous result, so it's 2. CD doesn't satisfy, so it's 2. And if we have the range, for example, this is 0, 1, 2, 3, and word 4. And if we have, for example, this, we have word BA that doesn't satisfy, we have the word ABA that satisfies, and we have the word EEE that satisfies the condition. So we have 2 words in total. So we can consider only condition of 3 and condition of 1. And instead of going through whole range from 1 to 3, we can just access to condition of 3 and condition of 1. Also, let's take a look at another example to check. Maybe should we consider some other ranges? So, if we have a range from 2 up to 3, we have word ABA with condition total 1, and we have word EEE, which is 2. So we have 2 words in total that satisfies the condition inside this range. But if we use the formula condition of 3 minus condition of 2, we will get 2 minus 1, you see 2 minus 1, which is 1. Why is this? Because we are considering range from 2 to 3. And we didn't take into consideration this part. So it's important that in comparison with the previous element, we added 1, this. So we actually need to consider a condition of end, it's okay, but minus condition of start minus 1, because this information is important to track whether for the purpose of our start, in this case 2, we added 1 or not. So that's important part. So let us check how we can implement such logic in code. The difference is here. If word satisfies the condition, we don't want to save only value 1 here, but we want to increase previously calculated value. So it's important to deal with the first one separately because we are doing j minus 1 here. For the first word, if it satisfies the condition, we are saving 1. If it doesn't satisfy the condition, we are saving number 0. And here we are going through 1 from 1 to end. And it's totally fine to use j minus 1 here. If not, otherwise, condition of j is just condition of j minus 1. We aren't adding anything. So it's the same as plus 0 here. And here we don't need whole for loop. So here we need to calculate condition of n minus condition of start minus 1. As we discussed, we need to take into consideration this change, whether for our start we have added 1, but the special case is when start is 0, we just need to take condition of n into consideration. Let us try to run and submit our code now. Okay. Okay, good. Now we are happier with that result. So let us compare these three solutions. So for the first solution, we had these constant operations, and we have big O of m memory. Here we have big O of m time complexity, and because of this for loop, we have length of start to end, and each for loop goes from start to end. And imagine we have from 0 to end of words. Word has length n, so in the worst case it can be O of n. So when we combine these for loops, in the worst case it can be big O of m times n. And here we are extracting our query, start and then limit, checking if the condition is satisfied. Inside this for loop, inner for loop, we have check is vowel for the first and for the last character. So we are calling this function 2 times. So we have 1, 2, 3, 4, and 5 checks in the worst case. So we have 2 checks of 5 parts. So we further have 10 checks for each iteration in the worst case. Next one that was accepted. So for the second solution, we have O of n plus O of m time complexity. And we have this for loop, which is big O of n. And we are checking whether the word satisfies the condition in each iteration. So we have 5 iterations of n times 5, which is the same as O of n. Here we have O of m, and as we discussed, O of n in the worst case. So we have O of m times n. So this solution wasn't accepted, but this was. Even though the constant doesn't make the essential difference between different classes of complexity, notice that here we had m times n times 10, and it wasn't accepted, but here we have only m times n, and it was accepted. So for the LeetCode constraints, even though these two classes of complexity are the same, it makes the difference, and the second one was accepted. But with small percentages. And let us take a look at our last submission. So we also have m plus n space complexity. Here we check whether the first word satisfies the condition. So it's constant operation of only 5 steps. Here we have big O of n, and we have this check, which is still big O of n. And here we have big O of m. So in total, we have only big O of n plus big O of m, which is equal to the greater value between n and m. So if n is greater than n, it's big O of n, and if m is greater than n, it's big O of m. So we have here linear time complexity, and it's accepted and beats 100%. Here we have quadratic complexity, and here as well. Here we have the best space complexity, but our solution isn't even accepted. Here and here we still have linear space complexity, but a bit worse than in the first one. But it doesn't matter because the last solution leads us to the best one. Thanks for watching. I hope you managed to solve the task efficiently using this video. And I hope this video helped you learn and understand better some concepts, including the prefix sum, which is not so beginner-friendly concept. Keep practicing, keep improving your skills, and see you in the future videos to continue learning together.